The following content is provided under a Creative Commons license. Your support will help MIT OpenCourseware continue to offer high-quality educational resources for free. To make a donation or view additional materials from hundreds of MIT courses, visit MIT OpenCourseware at ocw.mit.edu.
So today we're going to talk about cooking and stoves and charcoal, and then there will be plenty of time afterwards to work on your project stuff. Ken is here already, Amit is around here, and Amelia will be coming at 2, so everyone has a mentor to work with. Yeah, so we did the labs in reverse. So charcoal, we did the lab on Wednesday, and even though it's warmer today, I think the rain would have made it even less pleasant. So I think that was the right call. So we'll go through that a little bit more. Yeah, and I just explained everything else. So let's start just by talking about cooking in developing countries. So what do people cook, and what are their needs for cooking? Soups? Sweet potato? And how do they typically prepare that? Well, there's a wide variety, but so what are sort of the cooking things that you need to be able to do from an energy perspective? So, yeah. Anything else? Yeah, so that would be oven. Yep. Okay, cool. What else? Meat. And what do you do with meat, energy-wise? I'm sorry? Open fire. Anything else? So, stew. Anything else? Okay, what else? Rice. And that would be, is that captured here? Yep. Anything else? Beans.
Do you need high pressure for anything?
Yeah, pressure cookers exist. You don't see them a lot.
You don't need pressure, right, for anything?
No. Okay, so this is a modest list, but some things that are missing are bread is a staple in a lot of places, whether it's a tortilla or Indian flatbread or, yep.
No, I mean, I was just wondering, like, getting back to the pressure cooker.
Mm-hmm.
Like, how do you cook meat without a pressure cooker? Like, how do you reach that temperature? Like, if you wanted to cook it in water, wouldn't the water just boil if you don't, like, pressurize it? Like, wouldn't it just evaporate if you don't, like,
Yeah, so most people don't boil meat.
Oh, so they don't use water when they're preparing.
So
Just do it directly.
So I'm not saying that this might be a confusing way to present this. I'm not saying that every one of these requires every one of these.
Oh.
Just that these are some of the foods that you're cooking, and these are some of the ways that you're preparing them. So I'm just trying to make sure that all of these are captured, or that all the methods are captured, but not linking. Yeah, because I would be reluctant to eat boiled meat straight without any other preparing. Though I think like cabbage and corned beef and cabbage is boiled, so I think you can do it. Vegetables, yeah. Yep. So meat is kind of uncommon on most people's staples, so you get it infrequently. Rice and beans or other combos that make whole proteins are pretty common, and a lot of people live on rice and beans pretty much every day of their lives, with some tortillas sometimes, in Nicaragua certainly. Vegetables, oftentimes you grow some vegetables and they supplement, but you'll live on a staple of rice and beans, a lot of where we're working. And in terms of the cooking, so for all of these, there's sort of the range of you need low heat or you could need high heat. You can need an oven. So talking about sort of like direct fire hitting the pan, hitting the food, versus an oven is going to be more convective. And then yeah, and people are pretty picky about the control of their fire for most of the heating source for most of these options. And so you'll see the people who go to Grupo Phoenix will definitely see this. I don't know about Osso Phoenix and Osso ProStar, but at Grupo Phoenix, a lot of women, or a few women have gas stoves, but they still maintain their old style adobe wood because they will only cook their tortillas on wood. They just can't cook on gas in a way that they believe makes it acceptable tortilla. So that is one of the things that I want to emphasize today. I'm going to keep coming back to it, is that people understandably are very sensitive to how they cook and have very long-standing traditions. They are cooking the same way their moms cooked and their moms and their moms. And so proposing to someone to cook in a radically different way is challenging and is something people are going to resist for really understandable reasons. So we've got the low heat, the high heat, and the oven that sort of captures it all. With boiling water, you need high enough heat that you can actually boil water. And each of those is critical to most people, that you can't cook with zero, with only one, ideally. And so people who even just cook on like 3 stone fires with wood just get really good at regulating. The oven is sort of the optional one, that's the bonus. But people who cook with wood get really good at regulating their fire so that they can get their low heat or their high heat depending on what they want, because most people need to be able to do both. So what fuels are typically used? Wood, yep. I'm not asking radically crazy questions. I think there's another one that might come out in your mind. Yes. Yep. Yep. Some people also cook with just general biomass, so that might be corn stalks or hay or similar. It's not a great fire, but if it's what you've got, it's better than nothing, because one thing to note on most of these is you can get away with not cooking some of your vegetables, depending on how you fertilize them, if you did, but you can't cook bread, or you can't skip cooking all of these and expect to be able to digest them. And so cooking is a non-negotiable. It's, our basic human need, which is part of why there's such a high level of risk aversion, because you're asking people to change what they know is the thing that's keeping them alive and their family alive. So some things to just keep in mind generally about cooking is that all modern fuel increase with income except kerosene. So people tend to go from from dung to wood to charcoal to propane and kerosene, but then, to kerosene and then to propane. But people tend to stick to propane for a while because it's readily available and people get used to it. In urban areas, unsurprisingly, biomass is less common than in rural areas. And in those rural areas, people often just stick with biomass forever because, so even if you can afford it, it's still easier to get wood that you can chop down basically in your backyard than to go get propane. So you'll stick with it. And then another thing to think about is that even if people have enough income, if you can't get your LPG or electric stoves or whatever, if you don't have electricity, you don't have the infrastructure, you're not going to switch. And then we often think about what I just said about going into your quote backyard to gather wood, but a lot of people in relatively rural areas purchase their wood rather than collecting it, either for time reasons or because it's actually, there's so much deforestation that it's really hard to get the wood, both in terms of distance and in terms of legality, because often it's cutting down wood on other people's property, and so you are avoiding doing the directly illegal thing and just purchasing it. It's less common in Central America, where we'll be going, but in a lot of regions, cutting down wood for fuel is now a crime. And so, but there is no alternative cooking method. And so it still happens, but now it's illegal. And so it's become more challenging in that respect and more expensive. In terms of how people cook, it really ranges. In places that have similar levels of wealth, you can see huge variations. So there's LPG, electricity, kerosene, and wood in Guatemala, whereas here in Ghana, wood is really used very little, and charcoal really is used quite a bit more. So it varies place to place what people use, and a lot of that has to do with how far away the wood is, and therefore how expensive it is, and a lot of other factors. But you should not assume, sort of, this goes back to week one, like everyone cooks with wood in a developing country. It's very location specific, and even location within the country specific, what people are doing. The challenges with fuel are that it can be up to a third of people's income just to pay for fuel. And a third of your income is kind of insane if you imagine spending a third of your income on fuel. The poorest people in the US, or the ones who are paying the most, are paying less than 1% of their income on cooking fuel. So if you imagine going from something that costs you 1% of your income to 30%, that's getting really substantial. And people who are collecting it are sometimes, in some areas, spending up to 7 hours a day collecting firewood, which is basically the same impact in your family, that if you're spending 7 hours a day, you're not having any time to do anything else but get enough fuel for cooking your food. And then just looking at the energy densities of all of these. So wood charcoal and the charcoal that we made on Wednesday is very similar to wood charcoal. You can get really good wood charcoal that's better than ours, and you can get really junky wood charcoal that's worse than ours. So we're about in the middle there. Everything else that's a biomass, because it's not compressed and or processed, is going to be worse. Dung is quite poor, both on energy density as well as health, because you can imagine burning dung is worse than burning anything else. And then heating oil, all the things that we're used to generally, gas or electric. Well, electric doesn't really fit in here, but gas is certainly a whole lot better. And so, of course, people are going to switch to here if they can, but it's expensive and challenging. And just from a visual standpoint, these are all the cooking options to think about. So there's electricity, propane, wood. These are typically wood ovens, dung. This is the Gico stove that I'll show a little bit later, which can be used with charcoal. There's cooking, and then there's a variety of different cooking stoves that you can cook with, and then this is just a 3-stone fire. So you can see there's 3 stones here to support your pot, and then you feed your logs in this way to cook your food. So that's just a quick overview on cooking. We're going to get into it more, but I wanted to switch gears and do a quick estimation. And it says in teams of 2. If you want to do it in 3 or 4, that's fine too. But what's the energy required to boil a liter of water, and what's the efficiency to do so? Go. Yeah, so I want to talk a little bit about design considerations for stoves. as some of you may be working on those projects. So what do you think you have to worry about when you design a stove? Airflow? Yes, definitely. What else?
Installation.
Yep.
Environment.
The environment you're in?
As in close proximity near the environment. Like, just make sure there's nothing flammable nearby.
Okay.
It's
Yep.
a safe
So
environment.
safety.
Safety, yeah, safety.
Yep. Size? Yeah.
Heat source.
Heat source. Anything else?
Usability.
Yeah. So if you're cooking outside, certainly. I think I'm below the magic line, aren't I? Anything else? Yep.
Convenience, as in how long it takes to get time to use, and I guess it falls under usability, but whether or not it's intuitive, usability is already written on top of
So it is.
it. Yeah.
All right, well, this is a good start. To just give you a sense of the list that I came up with another person, there's the insulation and the thermal mass. And this is actually a complicated issue because in some cases, like with an oven, you want really, really good thermal mass. So you heat up that thermal mass, and then that thermal mass allows you to cook longer. Whereas for a charcoal stove, you don't want a big thermal mass. You don't want necessarily zero thermal mass, but if you have too much thermal mass, the charcoal will use all its energy in transferring it to the stove, and you won't be able to cook very much with it. Airflow is another important consideration. The reason the G-Co worked so poorly on Wednesday was actually because the door never got open. That was my fault. I realized that after when I was cleaning up, that we never opened the door, which meant there was no airflow, which pretty much limits the ability of the fuel to get hot. The volume, so yeah, which we mentioned, how much you're going to cook is huge. People have really varying needs there. Robustness to water, so I'm going to, the G-Co, one of the challenges with it is it's made of ceramic, which makes a really nice insulator, but as we talked about, if you pour water onto it to prevent put out the charcoal, the ceramic is going to crack. And also if you drop it, the ceramic is going to crack. But boiling water, it's pretty common for some water to run over the edge of the stove. And so that alone can cause cracking. The cost of the device is really critical, as this is such a fundamental need. Everyone needs one, and so if it's unaffordable, that's pretty problematic. Longevity is another concern. A lot of these metal stoves that I'll be showing in a second don't have a lot of longevity, but they are affordable. And so Paul Polak would be really happy with that balancing act. Other people would be less happy, but it is an issue. The heating options, so ideally you could have some magic stove where you could use any sort of fuel, right? You could use charcoal or wood or regular biomass or propane or electricity or whatever you could get. You'd have this magic stove, but that's not very realistic from the price standpoint. But people do like to be able to cook with a range of fuels. Ease of use is definitely important. If it's hard to light or hard to keep the fire lit or hard to get your pot on, it's a pretty unfortunate stove. Emissions is another thing to think about in terms of where does the smoke go. A lot of times it goes straight into the kitchen. You'll see in the homes in Nicaragua, the stoves look a lot like this. And even when they do have a chimney, it's rare that all 3 holes for the pots are covered. And so the chimney, in that situation, doesn't work very well. A lot of the smoke escapes. Efficiency, so how much of the heat actually gets to cook as opposed to doing something else. Style, aesthetics are all pretty important. People do want their kitchens to be attractive, and so while we're not talking about a criteria similar to does it look like the stainless steel kitchen in a high-end kitchen, or a professional stove in a high-end kitchen in the US, it's still a really critical thing to think about, and a really junky looking stove will not do very well. And then flexibility for cooking with different fuels or different types of foods, et cetera, et cetera. So I'm just gonna, if everyone can turn around, go to the back corner and show you a wide variety of stoves. So this is one of the stoves we used yesterday, and it's a pretty simple wood stove that's a relatively common design. So you can see that it has the upper surface for cooking with. I'm not really sure what if these are just decorative or if there's some purpose to them, but it did prevent us from using a certain pot yesterday, so it was a frustrating element.
Isn't it to hold pots with rings inside?
Yeah, so it might be to hold a special type of pot, absolutely. And then a place to catch the ash is pretty handy as well, so that the ash doesn't just fall on the ground. And it has plenty of holes for air to allow for airflow. The Gico, these 2 are called Gicos, which is a design of a stove that was developed in Africa, in Kenya, I believe. And the Gico has a ceramic part that holds your fuel and also acts as an insulator, and then metal everywhere else. This one was not made as carefully, and maybe a knockoff of this one, which you can see the ceramic liner is actually thicker on this one. So it works a little better. It has the door that allows you to control airflow, so that's a big improvement over this one, and the insulation. It has these 3 pieces which allow you to hold a smaller pot. It has little handles that may or may not work too well. This is pretty heavy for such small handles, so I don't like actually carrying it like that. But it's a quite improved stove in terms of efficiency. I believe it cuts fuel use down by like 30%, so it's significant. This is an interesting stove that, I don't know, can you see this at all, Eric?
I can.
Okay, great. So this is a knockoff Gico. And so you can see that it kind of looks like the Gico, but it's got a bigger door. It has some really monstrous handles that are actually easier to use than those, so that's a big improvement. But it actually has so much thermal mass in it that it gets to that issue of there's so much thermal mass that you use all your fuel heating the stove rather than cooking. And so it takes forever to cook with this, like a ridiculous amount of time. And so it's one of those like, well, if this much insulation is good, this must be better assumption that is really common. We actually, with our charcoal, we found that if we make a charcoal, that people like I'll talk about it more, but a bigger piece of charcoal that they can cut in half and make into the same pieces of charcoal that are identical in size, but they prefer the bigger size. And same with stoves, people tend to, bigger is better, is the assumption. These next 4 I'm going to show are all stoves I bought in Nicaragua. So this one is cool because it was a tire hub. So a nice use of recycling. These legs allowed it to actually be at this height, which was pretty great. However, for bringing it back on the airplane, I cut off the legs. Mostly charcoal in Nicaragua is used just for frying up food at places called fritangas. And so they're just done on the street corners, and it's a sales thing. It's rare to see these in people's homes. This is one, can anyone tell what this is made out of? So it's actually a gas cylinder that got cut up probably when it died, and then rebar is the grating. This one is really, really simple and just used out of sheet metal. It's galvanized, so if you use it inside, it's going to make people sick because the galvanized metal gives off fumes that are not so great. And then this one is an interesting design that's pretty common, usually made out of it's usually bigger. It's like a 55-gallon drum, but I couldn't bring that home on the airplane. And this one is interesting because it allows you to use charcoal or wood, because you can feed the wood in this way, like you would in a traditional adobe stove. And so it's nice that it does have that flexibility compared to all the others. So, and all of them generally come painted, and then the paint all chips away as you cook with it. But that does sort of speak to the aesthetics interest, that people want to buy a nice looking painted stove, even if the paint doesn't last very long. It helps them sell. Yeah?
One of the ones that we came up with last year was like really easy to make with wood sheet metal.
Yeah.
Is that really important in our designs? Or
so what that team identified was that it was important that this be made by the women locally. And so therefore, they decided that a single piece of sheet metal was going to be easier for the women to make locally than making it out of many pieces. You, as a team, if you end up working on that project, may come to a different conclusion. That's the conclusion they came up with. Yeah?
Do they have like access to like welding equipment?
So in Nicaragua, there's plenty of people who weld, mostly with oxyacetylene or stick welding. But in the rural villages, there aren't. And so, for example, in where Grupo Phoenix is, there isn't a welder in the village, in the community. But if you went up to Ocotal, you can find people who weld. So there's definitely welding capability. You should consider that local, but it's not something that like the women in the village could do. And so that's why they didn't come up with a welded stove, was because they wanted it to be something that the women could do themselves. So two really good resources are cookstove.net, which goes more into the theory of cook stoves, and Aprovecho, which is a huge organization that does a lot of stove design and testing, and they have a lot of great resources about how to design stoves, how to test stoves, etc. Are there any other questions about stoves? Okay, so I'm going to talk some more about charcoal. So 2.5 billion people cook with biomass. So that's sort of the market we're talking about, as opposed to people cooking with gas or electricity. And it's generally people living on less than $2 or $3 a day, though there is some wide range on that. And there's really no viable alternative. I'll talk about solar cookers a little later. Propane fuel is just unavailable, and same with the grid in these regions. And so cooking with biomass, which I got into a little, has some real problems. So there's 1.5 million people who die every year from indoor air pollution, and that's generally associated with cooking inside the home, smoking inside the home. There's other things that also contribute, but indoor air pollution from cooking is a huge one. And it's mostly women and children who are the ones tending the fires and taking the biggest hit here. So there was a study done that estimated that if everyone who currently cooks with wood or dung and straw and biomass that's raw switched to charcoal, half of those lives would be saved right off the bat with no added ventilation, no other changes, just switching from wood to charcoal because it's that much cleaner. But then you get into the environmental issue of, we're talking about regions that can be facing 6 to 10% deforestation rates in areas that are up to 98% deforested. And so if you encourage everyone to switch to charcoal, you're going to be using up more wood, and you're going to decimate the environment even further. And as I mentioned before, there's also a poverty aspect to cooking fuel in terms of how much money and or time it takes to be able to cook. So the charcoal that we talked about on Wednesday has some benefits in that it burns as cleanly as wood charcoal. It's using a true waste. The complicated part about using a true waste is that in every region, some of the possible wastes are not true wastes. And so corn cobs and stalks can be used in farms or any of these materials can be used in farms to replenish the soil, basically, except sugarcane, which really has no nutritive value once you press the sugar out of it. And so in places where people are using that to replenish the soil, it's a really bad idea to encourage them to switch to making charcoal from it because they're going to decimate their land, and the land is so valuable. However, in most farms that are at the subsistence level, you can find some biomass that's rotting, and so that's the biomass we target. So that's why we try to have a process that works with a huge variety of waste, so that you can use a wide variety of waste and only use the stuff that's waste. The nice thing about using the true waste is that it tends to be rotting in such a way that it's producing a lot of methane gas, which is one of the worst greenhouse gases, and worse for the environment than burning the material. And so there are actually areas where you get carbon credits just for burning sugarcane waste rather than letting it rot. And so here, rather than just helping the environment by burning it, we're using that fuel to cook with, as well as not getting the methane in the environment. So just to give you a sense of where this project is, so a few years ago we got a $200,000 grant from the World Bank to make charcoal, and so we trained more than 1,000 people in Haiti in the method, and we have some workshops or ateliers in Haiti that are making the charcoal now. Typically the costs associated with the charcoal are just the drum and the press, and so the drum is anywhere from $10 to $30 in a country, and the press generally is about $2 to make. If someone's telling you they're going to make it for 10, they're ripping you off. So push back, because most people do. When you talk to welders, most people talk about how expensive it is, but if you push, $2 is a pretty standard price we found almost everywhere. So the process that we went through yesterday was we took the raw waste, wrote it into a drum, lit it on fire, covered it. Then you're in an anaerobic environment for about 2 hours, and then you have your charcoal fines, which you crush in the bag-in-a-bag method in the rice husks, mixed with a binder made from yucca, briquette it, and then you can put the briquettes back in the drum to harden them after they've dried, and then you can cook with them. So I just want to make sure that you guys are all comfortable with this method, because you'll be doing it. Most of you will be doing it having only done it once. And so I just want to make sure you are feeling confident, and so that's why I'm reviewing it in so much detail. So when you load the drum, you need to remember to have the stick in the middle to make your chimney. You can use the fuses at the bottom to help light the drum, and it works really well to light from the bottom rather than the top. If you just light from the top, you'll get much less effective burning. When you're covering up the drum, again, first you see this smoke, and we saw very little of the just white smoke. We saw mostly yellow smoke. The just white smoke is water, and so if you're getting a ton of just white smoke, that means your waste is too dry. You're almost never going to see it as dry as we had on Wednesday, because too wet, excuse me, yeah, too dry. So you almost never see it as dry as we had on Wednesday, because that has been sitting in a heated, incredibly dry environment at MIT for about a year, and so that helps it dry out at a level that you're never going to see in the field, right? And that's why it was infected with cockroaches, because of all those, because it was spending so long in the bowels of MIT. So you will see some white smoke, but if that's all you're getting, that's an indicator that your stuff is too wet, or if the drum just won't catch on fire at all. And then you get the yellow smoke, and then you get the flame, and then you wait some period of time, and I'm sorry I can't give you a 7 minutes answer for how long you wait until you switch, but things to look for are, remember how it looked like this, but then you'd get puffs of the yellow smoke, and so you want to wait until you're no longer getting those puffs of yellow smoke, because those are areas that haven't gotten any heat yet that are now starting to catch on fire. And then later on, what cued me to cover it up was we were starting to get black smoke, and the black smoke tends to mean that we're burning everything really fast, and so that's why we needed to cover it up. But it is a judgment call, and it is tricky, and so there's no easy way. Everything from the humidity to the temperature to the type of the way that what was in the drum before. That's another thing to think about, is if when you get an oil drum, you don't know where you're getting it from, and so it may have oil in it, and so you may need to do like a pre-burn with just a little bit of material to burn out whatever junk is in the drum, so that you have a clean drum, clean-ish drum to use for carbonization, because you wouldn't want like oil impregnated briquettes, because that would burn pretty nastily. And you can do side-by-side carbonization if you have a few drums, which is nice. And then covering it up, just doing it relatively quickly, but also carefully so you don't get burned, because the drum is really hot at that point. For making the binder, just remembering that you're going for this really, it's not like consistency, so checking to make sure you get it before you use it, because if you don't, the briquettes will completely fall apart, and that's problematic. And then using the right amount so that you actually get a good briquette is important. And then briquetting. So I just wanted to show you a couple of other briquette press examples. So the presses we used yesterday are really simple, and I'll talk about how we got there. But there's a cup, an ejector pin, and a plunger. And the block is just because we don't have tables with holes in them around here, but it's pretty easy to find some sort of hole you can use, so you don't actually need a block. But you should, every team should plan to bring a press with you. And then ideally you can make them there, but it's nice to have one to show as an example to your welder. You can leave it there if you need to. In Haiti, our colleagues got tired of making one briquette at a time, so they came up with this press that makes 4 at a time and then has a plate that slides out, sort of like our old style press that I'll show you in a minute, to make 4 briquettes at a time. The problem is you're just increasing the area, so you're distributing the pressure, and so you really have to whale on this press to make briquettes well. In 2009, they made an extruding device to make briquettes, which is nice, but a lot of material. So yeah, and just when you briquette them, make sure you're hammering with enough force that you actually get well compacted briquettes, or else they won't, when they dry, they'll fall apart. So I want to talk a little bit about how the briquette press came to be, because I think a lot of D-Lab, you work on a project and then you're done, you hand it off to the community maybe, and it seems like that's all that it takes. And at least in this case, and I think in a lot of cases, there's more required to get to a good product. So initially we made briquettes just by hand, as you can see in this picture, and you can imagine compressing that material hard enough to get a really solid briquette was pretty painful on the hands, and it really didn't make very good briquettes, even if you were super strong compressing the briquettes. So then we looked at buying a briquette maker, and the mechanized ones that we could find were about $8,000 and entirely inappropriate. And so there was a bunch of work done by Jessica Veshicle to figure out the best method for actually making briquettes, and she honed in on impact forming them. And so she designed a briquette maker here, and so this was one of the earliest prototypes that had a handle. Actually, that's the handle for the door. Let me show you the next picture. I think it's easier to see. So you load your material in the top, and then it falls to the bottom. This door is closed. Then you put the plunger in, close it with a pin, hit it a few times, and then when you open this, this plate at the bottom has a pin sticking out the back, and so it hits the back pin, and that pushes the briquette out so you can grab it. So it's a really nice design, and it made 4 to 5 briquettes a minute, so we were pretty happy with it. But it was kind of slow and frustrating, and so the first improvement was to do a time study to figure out what was taking so long and how to improve it, and everything was taking a long time, but ejecting was taking like the most time, loading was taking a while, and so we, someone that Amy Smith worked with came up with an improvement which got us to 6 to 8 briquettes per minute. And so you can see that some of the improvements were, instead of loading from the very top, which required a lot more precision, you loaded from the side. And for ejecting, instead of having a special ejection mechanism which required a lot of cleaning, you just pulled this plate out and then dropped the briquette down. And then we actually, well, actually I can show you the presses. They're over here. So this one that you can see down here, it has this plate, and so the briquette drops down there like that plunger is trying to, and then when you close this drawer, it actually pushes the briquette out of the way, so it's a little bit mechanized, and so it helps it helps speed things up considerably. And so we were really happy with it, but it was also a relatively expensive design because this plate had to be quite thick, and this is a really expensive piece of metal just right here. And so we were pretty concerned about the prices of some of these elements. And so we had another person who does a lot of work in Guatemala take a look at it and redesign it. Unfortunately, I wasn't able to find one of these presses in D-Lab today, but he just made some subtle improvements so that that big plate was cut down until it was just as wide as the diameter of this shaft, and then everything else was made with angle iron. And angle iron is relatively cheap and available everywhere. And so that made it a whole lot more affordable for our partners. There are a variety of changes. And so you can see just looking at it, there's a bit less metal here is the biggest change, and that improved things a lot.
So that's not fully solidified. There's going to be some loss there.
There is. That was not, I would say, that very significant compared to actually this method. I think the method we have now is there's more waste, so that we just do it on a tarp so that we collect that waste. So we still weren't happy with the price, and so we ended up radically redesigning it by removing all of the material, basically, to just the most basic elements. And we started with a circular design, and that still stands, but we've also added a square design so that if you have cylindrical stock, you can use it, and if you don't, if you have square stock, you can use it. One of the nice things about square stock is that it's a little bit more flexible in terms of these parts, the two parts that you need to fit into the press. You don't need to cut a careful circle. You can just cut a square, and that's a lot easier. And then same on the bottom, you can just weld these pieces on. So we took that to the field, and we got a few different designs back as improvements. So this one is just used sheet metal that's bent around and then welded on the edges. And so that further reduced costs because it's thinner. It's a thick sheet, but not as thick. And then this group used angle iron, you can see, and put 4 pieces of angle iron together and welded the edges, which requires a talented welder, but if you have one, is a really nice way to do things. And so there's a whole variety of little improvements that are still being made, but generally we're very happy with this press. Now, it's interesting to note that some of our partners still prefer this press, as I mentioned, because of the whole bigger is better issue, that they just really like this because they feel like it's sturdier, even though it's 10 times the cost and has no additional value in terms of speed or labor comfort or anything like that. So that's been one of our challenges, is to people who saw this press first, they still want to use it because they prefer it despite the cost difference. And so that's one thing we're trying to work out, is how do we get that cachet into this press that is so much more affordable. So all that to said, and this is a lot of years of effort of improving in small and big ways. And so it's just worth thinking about all the different ways that a product needs to be improved past the initial prototype, which is the stage that you'll be getting to. So I wanted to make a couple other comments about running a training, because you guys will be doing, at least two of the 3 groups will be doing the charcoal trainings in the field. So just to start out with, do you guys have any questions about how you'll be running that training? Have you thought about it at all yet? How are you feeling about doing that? Yeah. Yeah, so your mentor, your trip leader has the contact for your community partner. And so you guys should be in contact with them to find out what is there and what needs to be brought. And you should also be reminding them right now that they need raw material the waste. They should be gathering that and drying it right now. Any other thoughts or comments? So just the one thing to think about is what's the balance between you doing a demonstration and you having the people there actually getting involved and getting their hands dirty and doing the work. And how do you balance that, both from a pedagogical standpoint, how do you help them learn this activity the best, and then also so making sure you have the dry waste that's truly dry is huge. Loading the drum, not getting cut, because people often get cut in that step. Making sure you really think before you light the drum on fire is critical, as well as making sure things are kind of calm during the fire, because oftentimes things get a little hectic. It's exciting when there's fire and things can get out of control, and we've had issues where like a drum got knocked over onto its side when we were covering it up because people were just too crazy. And so, you know, it's not insanely dangerous, but it is dangerous, and so it's worth just making sure you have that under control. Crushing is pretty easy when you have a big group because everyone takes a turn jumping on the bag, and that's really nice. Making sure you're gonna heat the water if you're gonna heat the water with the charcoal, with the burn, make sure you have that prepared. Yeah, those are the big ones. And then making sure everyone gets a chance to use the briquette press, because some people get really into it and don't want to give up the turn. So making sure you do that. All right, so the rest of the class is just time for you guys to work. I want to remind you to hand in these 4 documents so that you can travel. And then just don't forget to do your muddy cards. Are there any questions before you guys get into groups? Okay, cool.